In this scenario, it comes from, is on page 426 of this text, and we're going to be looking at tax returns. And the scenario is that you are an accounting firm and you are trying to figure out what your market potential is, or what your addressable market is going to be. And clearly, in this case, less than one half of people file them through an accountant or other tax professional. So you're working with you're working with a 50% at this point as far as an addressable market. The other half have already decided they're going to go it on their own and file their own taxes. So let's take this one from the top. And so you are the accounting firm, and you're trying to figure out whether what your revenue potential might be, or if what the market is actually looking like. And what you've done is you've gone out and you've done a survey of 1,002 people who file tax returns. Showed that 48% of them file through an accountant. Right? So that's your sample. Okay. Now you know that if you're kind of taking from the top, your givens are that your P, your capital P, by the way, is 0.5. You know that your P hat is equal to 0.48. That was given. You know your sample size. That was given as well, right here. 1,002 people. 1002. So having said all that, the reason why this research would be important is that you want to obviously locate in a place or location or a building where there's plenty of people around to do the taxes for, because that's what you make. That's how you make money. And so an appropriate research question would be, okay, does this sample size 0.48, does this sample of 1,002 with a p hat of 0.48, are those the same or are they different? Okay, and kind of put it in a little more common language. Is you're trying to figure out whether the market that you've examined of 0.48, if that's going to meet this 50% standard that you've established in order to open up an office in and around that location. Now, so the question is, are they the same, or is this 0.48, does that meet your standard of 50%? So a research appropriate null hypothesis is that they are the same. And they being this sample of 0.48 and 1,002 sample size, these 0.5 and 0.48 on a sample basis are the same. The alternate, as always, is they are not the same. If you're doing this mathematically, you'd look at p hat, which is 0.48, does not equal 0.5, and up here you would say p hat does equal 0.5 or p. The proportion is, there's a proportion analysis, as you probably surmise at this point. Okay, which type of testing would you use? We're going to do, well, we know a lot here, and so I'm actually going to use, we've got the, I'm going to use the z-table because I know a lot. I've got a nice solid sample size. I've got the proportion for the overall population, so I can run, or I will run a z-test. And I'm going to run a z and a two-tail. At what confidence level? As always, we are going to run this at 95% confidence level. Another way to put that is p less than 0.05, and p we're talking about is a probability, not the proportion, capital P. And then, another way you'd see this is, as always, is a sig 0.05. Kind of a scripted sig 0.05. Now, these givens. Everything is pretty well laying out as far as solving the problem. So you want to calculate. Next thing you want to do is you want to calculate your test statistic. We know that z, we're going to use a z table, is p hat minus p, and we're going to do this at the square root of p times q divided by, and this goes all the way down, over n. And q, as you know, is equal to 1 minus the proportion. Okay, or actually the proportion for the sample. And so now you pretty much know what's what you're calculating out here. So you're asking yourself, is this 0.48 from the sample? Okay, is that going to be the same or different? So we're going to go z is equal to 0.48 minus 0.5 divided by p times q. P we know is 0.48. Q is 0.6 over n, and then we're to a square root. Now, if you calculated that out, you would come up with a test statistic of minus 1.27. The next step, so you've got your test statistic. You're going to go to your it's a negative 1.27, so you're going to go to your negative z table. That'll be down here when we when we actually start looking up some of the additional information. But okay. And you want to figure out what is the upper and lower critical values. So you got your test statistic. Now what you got to do is you're going to be setting up your model down here. And it's a two-tail, and all you got to do is get those z values and then run your test statistic against those z values. So at a 95% confidence interval, right, is what we're doing, 95%. And remember, you got to divide that, the 1 minus 0.95 is 0.05 divided by 2 is 0.025. And so now you come in here on your handy dandy chart. Let's go to positive z. Positive z. And so now we know that 1 minus 0.025 is 0.975. And 0.975, if I can find it real quick like here, 0.975. Yep, there it is. And this is 1.96. And the way I got that, once again, was I did this at 95%. Remember that I'm doing a two-tail analysis, so I have to divide that by 2. 1 minus 0.025 is 0.975. And so now I know that my critical value on the upper end is going to be 1.96. And on the lower end, it's going to be minus 1.96. Now, let's keep moving ahead here. So we know that this is 1.96, and this is positive 1.96. And we set this up as the do not reject HO. Put these up here. This is our null HO, and this is our alternate. And so we're going to decide whether this z statistic falls in the reject or do not reject. And as you can see here, minus 1.27 falls in the do not reject. So I think you see where this is going. You're going to be in the do not reject HO, or lack of evidence to conclude that the null should be rejected. Now the other thing you can do here, okay, is you know that your test statistic is minus 1.27, so you could also come in here and minus 1.2, and then you're at a 7, okay, is 0.1020, and you know that's clearly your we're looking at a situation where you're up over the P.05 at that point. Okay? And then, in order to get that back to where it was as far as 95% confidence level, you'd have to double that. So you're well over P.05. So you're going to be rejecting this situation as well. Now, or you're going to be rejecting the alternate and accepting the null. So you're going to accept the null at P less than .05. You fill in here, and you also look here, and you say, okay, wait a minute, you're definitely up over that 0.05 value, even before you start working that back into the 95%. But regardless, what is the p-value? We've got that, less than .05, and what is the answer to the research question? The original research question is, are these two numbers, the p.5 and the p.48, are those the same, and does that meet this 50% standard that you set up in order to decide whether to set up shop there? And so basically what you're saying here is that you're accepting the null, therefore these two numbers are the same, you've met your standard, and you're going to set up shop in that location. And you're going to do that because you conducted the analysis at P.05. You figured out that you're, based upon the Z table, that you're going to be less than .05. You confirm, or that you're going to be greater than 0.05. You confirm that here. And as far as your test model goes, because you ran the 1.27 test statistic against that. And that is how you would go about supporting, remember, support your conclusions and recommendations with specific values. Be sure to use all this information that you've gathered up to this point in order to support your conclusions and recommendations and answer the question that you would, these are the same, go ahead and set up shop at that specific location.